Well, you can form so-called beam pattern. All right. So if there's a target, here, you can form a beam to point at the target, and likewise there may be a target over here. So you do spatial processing. Follow? So you can separate this target from that target doing array beam forming. Alright, so this is separation in space. So these are the few basic approach. Engineers, scientists work very hard is to basically find different dimension or different division to separate signals, and that is what we mean by improving signal to noise ratio. To be able to separate one from the other one, or improve the signal to interference plus noise ratio. But for this case, because you are going to get the Carter return, and you notice that you are flying in this direction, for the terrain around here, the return Doppler frequency is 0 error, right? But the mountain over there will give you a much higher return Doppler frequency. You follow? But at what speed are you traveling at your airborne radar? At a constant speed. But the frequencies component that you receive from the terrain here and from the terrain there, they are actually different. So therefore, you end up with a relatively broadband frequency spectrum to deal with, right? And that's why we have to look at the so-called step processing. And that's the reason why we introduced the step processor earlier on, space-time. We say that it's a broadband structure, right? It's because we needed to tackle such a situation. Okay, so this is your airborne radar. So the antenna array on board may form a certain beam pattern. Alright, so the beam should be pointing at the target. That is what you want to do, right? To intercept the signal. But you get all kind of return signal from all directions due to your terrain, and this is your Carter signal. Alright, so for a fixed range, well, you are able to actually form the power spectrum density, and that is known as the ISO range Carter range, and that will give you this plot. Right. So here you have we have a 3D plot. This corresponds to angle of arrival, and this corresponds to your Doppler frequency. So this may be your target. Now the return due to your terrain, which means in this case your Carter signal, may give you briefly the shape of your array beam pattern, alright, in your spatial domain. And as for your Doppler frequency or frequency domain, or because of the Doppler shift, as I said earlier on, the Doppler shift gives rise to broadband signal. So you can see that, well, you will see that your target will be embedded in your background power spectrum. So in both frequency domain and directional domain, well, you see that the target is actually hiding inside the Carter signal. Alright, so that is a problem. And now the worst thing is, sometimes your enemy may purposely jam you, so you may have so-called jammer. Jammer is actually an artificial signal produced by your enemy. You are trying to perform radar detection and so on. So maybe you are talking about electronic warfare. So somebody may use a very high power transmitter to generate a